And I'm going to mute because it's really noisy here.
Thanks, Greg. Well, hey everyone, I'm happy to be here today to give you an update on the dev team's work and also to introduce you to Artur, who's going to give us a demo on some of the wallet work that's been happening. But first, let me talk a little bit about what we've been doing. Let me share my screen here and throw a link here in the chat window. This is the page that I'm speaking to. You're welcome to pull it up and follow along. We are nearing the end of our current sprint, where our priorities are public testnet monitoring, long-running testing, and improvements to support consensus performance. You're welcome to take a look at what's planned for our node 9.1, which we will use as the version of Node for our release of public testnet. So you're welcome to take a look and see what's in that. There will be some other items coming in the next day or so. So we're looking forward to wrapping that up and getting that release tagged and out. As always, you can follow along on what we're working towards Mercury in our features doc. Testnet, we are planning to launch a testnet 1 this week. You can use the link here on the screen to find out more information about that public testnet. There are currently no known blockers against the delivery of testnet 1, and we are working very fast and furiously to get it out. And I'll talk a little bit more about what's going into that, but that is our current plan. We are really grateful for our community testers. Last week we ran our community testers worked against a version of the public testnet, and we were very pleased with how that worked out. We will do something similar again in our testing session tomorrow at 1400 UTC. And as always, we welcome node operators. We welcome of all levels and abilities, and observers. You're always welcome to join us for community testing. I think we have a pretty good time. Consensus. We are testing a fix towards our justification regression bug. And Danyar and Kent are working on that. And so it's something that they've got a PR for, and they're taking a look to see if it would resolve this issue. This is a bug that's not blocking bonding. We see people successfully bonding. It's after, it's later after they have bonded that we're seeing this justification regression, and that's what's going on there. That's not a blocker to testnet 1 because we're not going to be bonding new validators as part of that release. The consensus team is also working to support both the wallet and nodes teams related to signing of deployments and rejection of unsigned deployments. Cost accounting. Please join me in celebrating the resolution to an issue we saw in last week in cost accounting, trying to figure out why running out of flow doesn't stop evaluation and execution in all branches. Kudos to Wakash and his work there. And now we are completely complete on the implementation of pure common cost accounting across the interpreter. And so really kudos to the team there. That was a big lift, and we're glad to have that complete. We are now completing the work to make that happy union between cost accounting and wallet. Basically, at the end of the day, you want to know as a deployer that your deployment has a cost. You want to see that come out of your token vault, and you want to see it moved into another vault that helps support your deployment. So that is the final work that we're getting in. That work is very much in progress, and we plan to demo this as part of this call next week. The node team, we've added some new configuration options for node operators related to max message size and packet chunk size. In general, if you're a node operator, we do recommend that you use the default. We believe that the default settings are going to support you. However, there are some edge cases, and that's why we've provided these options for configuration, where you might need to be more specific in either specifying your max message size or your packet chunk size. And if you think you are one of those people, do please take a look at this ticket, RChain 3117. It will give you a lot more information about what considerations you should make if you wanted to choose to customize and not run against default. We have work in progress for removing the max number of connections for node, and this is This is a concern that we have of the possibility, it's not happening always, but it would be an edge case for a node, and especially a node like a bootstrap node, rejecting new peers due to the current implementation of Kademlia. So Sebastian is working on this to make sure that we have a good process in place for maintaining relationships with active nodes and saying goodbye to those nodes that are no longer active, and that we won't run the risk of rejecting new peers who might want to come into the network. RSpace, last week on after this call last week, we discovered a fairly critical issue that would be a blocker to the success of mainnet related to how RSpace supports Casper, largely related to memory and storage, and the ability to build long chains. So the good news is we have a short-term fix in place. It is absolutely not a blocker to any of our versions of testnet. And we also understand what the long-term fix is and have pivoted to developers full-time on that. And so you can take a look at RChain 3138. That work has started, and we're very optimistic about how this change will best support Casper as we move forward and working towards mainnet. Let's see, test infrastructure, testnet support. Tomasz is working and doing some fine tuning related to the testnet infrastructure and monitoring, and very much ready to launch testnet 1 this week. Performance testing, we are working towards automation of our performance test harness so that it runs on PRs merging to dev. And we also have work in progress to automate what we call long-running tests. These are tests that take typically more than 5 hours. In general, they're building blockchains of hundreds of blocks, and clearly cannot run in our CI/CD environment just because it takes so long. And we do want to make sure that we run them regularly because they're important to our quality assurance. So we are working on getting into place, running that long-running test in an automated format, and Adam's almost complete with that. And finally, the wallet work. We're just tying off some work to ensure support for signing and validating of signatures of deployments, as well as some work. There are a couple PRs that are in that will update the Vault API, and I'll let Artur talk a lot more about that. But at this point, let me just pause. Are there any questions about what we're working on this week? I will take that as a no. So I'm glad.
I thought your description was exceptionally lucid this week, and it is a very concise and clear presentation of all the issues that we sort of have been putting up and knocking down.
Yeah, it's a lot like that. We've this is a interesting project for that, and there's sometimes you learn new things along the way, and I'm really grateful for the team on their ability to not only recognize changes when they occur, but also to pivot very quickly and be responsive to that. I have the privilege of working with some really people with just great attitude towards this work. I'm very grateful for that. All right, if there are no other questions about what we're working on this week, what I'd like to do is to turn the time over to Artur so that he can demonstrate for you how things are working in a scenario where we would like Alice to pay Bob. Artur, are you there?
Hi, everyone. Can you hear me?
Yes, thank you.
Cool.
Yes.
Let me share my screen. So here it is. Can you see it?
Yes.
Okay, so I've got my terminal split into three windows. In the left, in the upper left, I'm going to execute commands. In the right one, there's a node running. You can't see it yet, but yeah, it's running. And here's my demo script. And what I'm going to present right now is the zeroth, I'd say, version of the Vaults API. Vaults, or wallets as we used to call them, we decided to change the name, as you might be aware, because usually wallets are things that are happening off chain. And yeah, so an account would be a vault. And yeah, so let's first of all see how a end user would access their vault. So I'm going to execute this command. I'm going to deploy and propose a script that can be seen in here, and I am going to execute using Alice's private key. Once I execute this command, you'll notice, you'll see the actual command that is going to be executed underneath, which is this. And you can see that node deploy now accepts additional parameter, namely private key. And this is a new thing added recently, and is very important. We are going to ultimately make it mandatory, and this is, if not for another reason, then you won't guarantee that the validator you're deploying at won't be able to tamper with the code you're deploying. And the way to achieve that is signing it using a private key provided to the node client. I'd like to interject to mention that I will welcome questions probably at the end of each section. If something is really blocking you from further understanding, then feel free to interject me. Yeah, so what we can see at the right is the code that has been deployed, and below are the results of the execution. I am logging the results to console using this small rolling snippet that deploys it to a public demo channel for inspection using show blocks or listen name. And I also output them to standard out, which ends up in node logs, because that's the easiest and most convenient way to present that to you today. So let's first go through the results of the execution of the above script, and then we'll dive into how the code is structured. So first of all, we are printing out the public key that we're executing with. That is obtained using this call, get deploy public key, and this is a util that calls into get deploy data, which is a system contract, which you can see, defined here, imported here. But I should probably stick to the results. So we're deploying using this public key. We are using it to obtain a deployer's public key bound vault. That's one type of vault that we are going to have. Another would be a standalone vault that would be associated with an unforgeable name and would be a basis for implementing various authentication schemes around vaults, like a multi-sig. But that's out of the scope of this demo so far. So we are unlocking the vault so that we can access it, and the unlocking succeeded because we were executing as the owner of that particular vault, and we were able to successfully check that the balance is 100. So let's go through the code that's been deployed in here. So here's your standard preamble of imports and name definitions that we are going to use below. We do a registry lookup for the ref vault contract. We log what source are we executing right now. We access our public key using this util contract that is delegating to the get deploy data system contract. And by the way, this most likely is going to no longer be possible in the nearest future, because that poses a certain security risk which we would like to avoid. So don't. We will provide a better, safer way for accessing the vault. And if you write any contracts, please don't use this method, because it is very likely to not be accessible to non-system contracts. Having said that, so once we've got the public key, we can obtain the ref vault associated with it. And I was mentioning that this is the 0th version of the API, and I'll be honest with you, I'm very frustrated, because I was just around the corner of presenting you the first or the much simpler version of the API, and yeah. A bug prevented me from doing that. So let it just be known that this is going to be simpler. We won't be passing public keys. We will be accessing ref vaults using ref addresses, which are derived from public keys, at least for the public key bound vault. But yeah, that's let's keep it at that. So. We access our vault using find or create and the public key, and we match on the result, and we expect it to be a write and having a vault on the second element of the tuple we are matching here. So what's happening here is most of the ref vault methods are returning a value of type similar to, that if you're familiar with Scala, Haskell, or whatever functional language, you recognize that immediately. And because of its usefulness in error handling, we've decided to adopt it in Rolang. So here's your iter type that takes 2 parameters, and the first would be the string signifying the potential error message if the call failed, and if it succeeded, the iter contains a value of the return type. So yeah, the values are either a tuple of 2 elements with left on the first element. Left on the first element and the error message on the second, or right on the first element of the tuple to signify that the call was successful and the actual results of the call. And we are, that's one of the changes I would be presenting to you, if not the bug. It would be much, this would be the next version of that type, which has the advantage of not allowing a typo in here. And this is probably going to be, I don't know, for sure the next testnet is going to have that, as long as also with all the changes I'm mentioning that are going to happen. So we've obtained our vault. We've seen that the result of find or create was successful. We are unlocking the vault, and this is being done by sending unlock command, calling the unlock method on the wrapper around the ref vault that we've obtained, because the way that access control is implemented in this version of the vault's API is that you receive the vault wrapped in yet another Rolang contract that has a very simple API with one method called unlock, which is going to succeed if and only if the deployer is the owner of that authentication wrapper. So since we were executing as Alice, which can be seen here, we used Alice's private key to access her own vault. Then this is going to succeed. Otherwise, we'd see this message printed out. And once the unlocking succeeded, we were able to check the balance of the vault and log it out to the standard out. And as I mentioned, this is going to be simplified a lot. We won't be restricting access to the balance method. Only the transfer method is going to be secured because the balance is public anyway. The data on the blockchain are public, so we won't be restricting that. So the code needed for just checking a balance is going to be very, very much simplified. But yeah, that's the way it works so far, and is going to work tomorrow once we deploy the testnet. So having discussed how we access the vault and check the balance, I would welcome your questions if you have any for this section.
Very thorough. Thank you for the explanation.
Okay, so I take that as no more questions. Let's proceed to the next part of the demo. So we were able to access the default and check the balance, but what we would really like to do probably is doing some transfers. So let's do that. And the only things we need to know to perform a transfer is having access to our own vault and knowing the rev address of the destination. So I'm going to execute this contract. Yeah. That doesn't. Okay. Yeah. So I'm executing as Alice the script that we are about to see here, and I'm substituting the string rev address with Bob's rev address. Yeah. So I'm not sure if, okay, yeah, so that worked. Okay, so well, let's go through the results. So we've been executing this source. We're logging the public key. We are beginning the transfer of 100 rev to this and that rev address. And that's basically it. The repetition you see here, if you're wondering, is because of this very script being executed in the replay R space as well. So yeah, so that we test that replays are deterministic on each deploy. So let's focus on just this. So we see just two things being printed out: deploy public key, beginning transfer. We don't see any message signifying that transfer has been finished. This is okay though. This is going to happen later. Let's go through the code. So the preamble stays the same. Here's a match on a tuple of two elements that are, and those values are being bound to those variables. This is so that I can, in a simple way, substitute the placeholders with values and bind them to variables. And we are accessing a vault and unlocking it using this util contract. So unlocking the vault you've seen previously, now we simply return the unlocked vault. so this is closer to the target interface that we are going to be using after the second version of the API. We are beginning the transfer, and to do the transfer, we call on the vault the method transfer, passing it the ref address, the amount to be transferred, and the result channel, so that we can be notified once that is finished, and whether it's succeeded or not. And what's going to change here is we are going to have yet another parameter, which is going to be the auth key for the vault. That is going to be to secure the call to transfer method after we no longer have the authentication wrapper around. And yeah, I guess that covers this snippet. Are there any questions? Okay, let's continue then. So let's check that despite the transfer haven't been finished, Alice's account has actually funds deducted. So expect this execution to print that there is balance 0 in Alice's account, and indeed the balance is 0. So have we burned our rev? We are about to find out in the next part of the demo. So let's go to that. Oh yeah, and a couple remarks. First of all, an exchange would do the transfer in exactly the same way any other end user would do. So they would access their one of their vaults and transfer to the ref address, whether there is a vault already waiting under that address or not. That's part of that's the reason why we haven't seen the finished message yet. Because the transfer method takes just a ref address and not a ref vault, we are going to be able to exchange transfers between various kinds of ref vaults wrapped in various authentication wrappers. So yeah, you could have a multi-sig transferring to a plain user's ref vault and all kinds of stuff, which is really expected, but I thought it's worth mentioning. And yeah, the logbox is the authentication wrapper that I was mentioning previously. And yeah, have we burnt our ref? Let's see that. Right now, we are going to onboard a friend on the platform, and this is subject to change because this is going to be transparent. But I'm demoing that mainly to show that the transfer can be kind of asynchronous. So there isn't yet a ref vault for Bob, but I'm going to create it just right now based on Bob's public key, and the transfer is going to finish once this is done. So as expected, we see that the transfer of 100 ref to Bob's ref address succeeded, and the result was right and nil because yeah, there's no interesting result other than it being successful. And
that by the way is lovely, demonstrating the asynchronous, essentially the suspension of the transaction until you've created the rev vault for Bob. That's lovely, very nice.
Thank you. I'm glad you appreciate that. So yeah, let's go through the execution. We've created a vault for that public key. In the next version of the demo, this is going to just say the ref address. Here's the ref address printed out. Let's try to use it. in the meantime, the transfer has finished, and whoa, what happened? Unlocking failed, but that is good because we are a third party to Bob, and we can still be friends because we weren't able to access his precious funds that have just arrived. So yeah, it would be a shame if we actually were able to unlock the default we've just created for him. But this is all of no concern because in the future version, how it's going to work, the only thing needed to onboard a user is going to be sending some rev to the rev address corresponding to the public key that they are going to be using. And then they can do deploys, I don't know, they can ask for balance of the rev address by deploying a contract. And as long as the rev transferred is going to cover the execution of ask for balance contract, yeah, we're golden. So the user's rev address, user's rev vault is going to be created, the balance is going to be asked for, and everything is going to work. So there will not really be other step for onboarding a user than just transferring the funds to their future rev address. So let's go through the code of this. So the preamble is standard. What we're doing is we're doing basically the same thing that is done to access our own rev vault. We call find or create, and I guess the two takeaways of this part of the demo is that the transfer can be initiated successfully even before the target user has their vault created. And the second one is that the authentication scheme is secure in the third parties not being able to access others' vaults. And yeah, there's a possibility that we are going to leverage in the future, that the user is going to actually call this find or create method themselves. Yeah. Any questions for this part of the demo? Okay, let's proceed then. Yeah, let's see that Bob actually has their vault created and that the balance is as expected, which is to say that the balance is 100. Yep, it works. So let's now see that we are able to transfer the funds back. So we've seen Bob's balance to be 100, which I won't be checking again. I'm also going to check the balance of the Genesis vault, which begs for a word of explanation. So what is a Genesis vault? A Genesis vault or Genesis vaults are going to be a set of vaults pre-deployed and pre-populated with funds for the testnet 1 and probably subsequent testnets. And the access to those vaults is going to be granted to testnet operators. Hopefully there would be a non-human testnet operator with which you could interact via Discord, namely a Hubot bot that would accept, okay, please send me some rev to this rev address, and yeah, you would get some rev transferred from that Genesis vault. Until we have such automation, the only difference is going to be that you are going to interact with a human being on the other side of the Discord chat. So yeah, hope that doesn't matter. And the Genesis Vault, so far, it is created in a different way. That's very much a implementation detail that we are going to change. That's one thing, and second thing is that it won't be accessible to the end users. So yeah, that's for that. So I'm going to not really create, but just check the balance of the Genesis Vault, and it is almost 9,000. So let's see what happens once we transfer back to the Genesis Vault. This is mainly to show that that a Genesis Vault is just like any other vaults, except for it being pre-populated and yeah, having different access scheme. So we've begun the transfer, we've finished the transfer, and we can check the balances again. So Bob's balance should be 0. Yeah, we're going to unify that access to the Genesis vaults with the end user vaults. And the balance of the Genesis vault is 9,000. So, are there any questions for the stuff covered so far? Okay, so let's go on. Let's check some error scenarios. So one error scenario would be to try to transfer when there are not enough funds, and there aren't enough funds in Alice's vault to transfer. So let's do that. By the way, the transfer amount, you probably have noticed, is hard-coded to be 100 just for simplicity of the demo. Oh, that's interesting. Have I pasted the wrong command, or what happened actually? Oh yeah, no, it's all right. I was misled by there being a finished message, but the result is left insufficient funds. So the transfer hasn't succeeded. This is as expected. How do I show you that? Probably by showing that Bob still has 0 rev. Because we were transferring to Bob. So let's see that. Yes, balance is 0. And then let's try to transfer to an invalid rev address, which should output an error result saying that something along the lines of rev address format not being correct. Yeah, invalid base 58 encoding. So this is mainly to show you how you would receive the information that the transfer wasn't successful. Yeah, and one thing to note is that the ref address validation. So the ref address in itself contains a checksum that is used to catch errors, catch typos in the ref address. But if we somehow pulled off having a typo that would result in a correct checksum, which is possible, but probably needs more than one typo. And yeah, and if the length of the ref address is correct, if the checksum is correct, the funds are lost until we manage to find a private key that would correspond to that ref address. But if we are actually able to do that, then we have bigger issues to tackle, because it means that all we know about cryptography is no longer true. So we should be pretty much sure that having a typo that would not be caught by the checksum would mean that the funds are lost. So if you want to ever burn any ref, there is such a possibility. And you're welcome to do that, I guess. With that optimistic accent, I guess I would issue the final call for your questions. And thank you for your attention.
Many thanks, Archer.
Thank you, Archer. That was a really very nice demo. One question. So what's the size of the network you're running this on?
Oh, that's just my local node. So there's not really a network.
Just checking.
Yeah, it would work exactly the same, if not for the delays.
Got it. Any other questions from the community? Going once? Going twice? Thanks again, Artur. Really appreciate it.
Thanks.
Many thanks.
So Kelly, is that the end of the technical update?
Yep.
Awesome. Well, that was really great. This is where we wanted to be. I just want to point out to the community that in September we demonstrated a much impoverished version of Alice Pays Bob, and then a couple of months ago we had Dan Connolly demonstrate a more sophisticated version of Alice Pays Bob, and now we have sort of feature complete on the wallets, command line wallets, and the features that are associated with that. So that sort of is the demonstration that we're on track to deliver the things that we said we'd deliver in October 27 at the annual general members meeting. It's been quite a journey, but we're definitely step by step getting all the way to the finish line. And concomitant with sort of reaching these milestones, we have to be looking forward. And so, as I mentioned several times, 2019 is sort of the year of the enterprise partnerships. So I'm out here in New York speaking with a potential enterprise partner, and that was a very good meeting. Lilia also attended the meeting with me, and she can confirm that we had a lot of good engagement, and there will definitely be some significant follow-up in the next few days. I fly back out tonight, and in order to get to a 1 o'clock meeting tomorrow at a very large software company in Redmond. This will be an important follow-up meeting to a sequence of communications that have preceded it, and there will be good engagement both at the technical level and at the business level. So we're quite excited about that engagement. And then it turns out that one of our board members presented this week to British Gas, and there is a possibility of engagement there. So we are making a lot of headway on exactly the aim and the goal of 2019, which are these enterprise partnerships. I will take questions about that in the closed session member Q&A, but I just wanted people to know on this call that we haven't been resting on our laurels at all. There's been quite a flurry of engagement with potential partners and potential engagements, business partnerships that will both help our partners and help promote the platform. So I won't really take a lot of questions about that until Friday at 11. And with that, unless there are any burning questions from the community, I think it's probably a good time to close out the call. Going once, going twice. Thanks to everyone. See you next week.